All right, welcome everybody to today's live stream. Today we're going to talk about data observability because let's face it, data quality is still one of the biggest issues that we have, and we need to keep a track of it. We need to fix problems all the time, and usually that's where data observability comes in, and very often we don't have good solutions. So let me quickly bring in our guests, Ryan Yackel and Eric Jones from IBM Databand. Hey guys.
What's going on?
Hello.
Hey. And so we're going to talk about use cases today. We're going to talk about how to very easily actually implement this, because I guess it can be a big pain, right, guys?
Yeah, I think, part of this presentation today is kind of go through maybe some of the trends we're seeing in the space and then where to focus your implementation efforts. At least there's two areas that we would say you got to tackle first and then build on that from there. So what we'll do is we'll kind of go through a quick kind of state of the union sort of a thing, give off some use cases we're seeing with our customers. I'll talk about a little bit of a customer story as well. And then Eric will actually show all this in action. So he'll bring in some examples of with how Databand plug and plays directly into simple integrations like ADF or Airflow, and then maybe a more complex integration you're looking for. We have a new public API that we're excited about. That we actually have an API contest going on right now internally within IBM, where we've got 30 or so submissions of internal tech people building out integrations with their catalogs or orchestration tools, things like that. So it's pretty cool to see just different layers of observability and how that's being used in organizations today.
Nice. Yeah, that's also something I'm very interested in, because you need a simple way to integrate this capability into your pipelines, into your existing tools. And so, yeah Eric, I'm excited to see what you're also going to show.
Sure.
Yeah, do you want to kick this off, Ryan?
Yeah, I'll kick it off. Yeah, thanks for everybody who's here. And if you're not here live, that's okay. We'll be able to have this on replay. So
yep, we're going to have this on YouTube. So also I'm going to keep track of the comments on YouTube. So we're going to answer them also afterwards.
Yeah, if you have questions, please ask along the way. We're excited to answer any questions you all may have. This space is still emerging, so definitely want to make sure we're addressing anything, especially if you just need to understand it from a industry perspective or any other questions related to that. We're happy to answer those questions.
Yeah.
Cool. All right. Let's go. All right. So real quick, I'm Eric. Or sorry, I'm on Eric. Eric's on the line. Me and Eric work with IBM Databand. We're part of the go-to-market team and also the product management team. Databand was acquired about a year ago by IBM, and so it complements their overall data fabric and data and AI platform, a part of IBM.
I know time flies, but it was actually 2 years ago.
Oh, 2 years ago. Sorry. Yeah. So we've been here for 2 years now. So thanks, Eric, for that reminder. So we part of that 2-year journey, obviously we rolled into overall the IBM Data Fabric story. And what we want to do today is hone in on the data observability component, which is what we do here at IBM Databand. So I'm going to go over some quick developments from the data and AI space and how that's impacting data observability. Talk about some of those top use cases I mentioned for data observability. I'm going to go over a customer story, and then we're going to see all this kind of in action so you can get the teeth of it and it not be something that's theoretical or something that we're just talking about that you may not even know how to implement. We want to make sure you can actually take something away from this practically and technically towards the end of the demo here. So the first thing is this is a report from the hype cycle for data management back in 2023. And before previous hype cycles from Gartner, it showed that basically data observability was this nice to have kind of solution. Within your organization, data quality and data observability, you needed those, but data quality was probably the traditional way of viewing data quality was the main thing people highlighted: data quality and data governance. Now what's happened is they've kind of moved this up into more of from the benefit, not just hey, this is a moderate benefit now it's a high benefit. And it's kind of moved from this nice to have to need to have with enterprises that have large data engineering teams, large analytics engineering teams, data platform teams. They're consuming, tons and tons of data, hundreds to thousands of different pipelines that they're managing on a day-to-day basis. Data observability is seen as that must-have area within data teams today. Similar to how data ops and master data management and data engineering, these other things, obviously, all these things kind of come together and making sure that observability is that component that sits on top of these tools to make sure that you're catching issues and resolving them as fast as you can. So that's where data observability is on the hype cycle. And kind of what that means for the market is, well, it's moved to this idea that observability helps with this foundation for reliable data, as I mentioned.
Ryan, before I have a question.
Yeah.
With the hype cycle, can you go back to the hype cycle?
Sure.
Because as I said in the beginning, I think this is one of the big issues that engineers face. I faced before. You have no observability. Something goes wrong. You have no idea it's happening or what exactly is happening. So, how fast do you think this will actually move through the whole hype cycle? Because that's usually a thing, right? How long will it take? What do you guess? Here it says 2 to 5 years.
I think that's, I don't want to speak for Gartner, but I think that's probably a good estimate. But I would say that I would say from maybe a year ago, it moved dramatically from just being this moderate view of that you need from observability to this kind of need to have thing now. So before, I would say probably a year and a half ago, maybe even 2 years ago, there was still this misunderstanding between like what observability is and what data quality is. We're using a lot of the same words here, but really at the end of the day is data observability, it pulls from a lot of the same things with data quality as it relates to looking at your data pipelines, data content, data freshness, things like that. But it goes beyond that, and it doesn't just tell you if things are wrong, it tells you what things you need to do to go fix them. And what it also does is it looks at data as it's in motion and not something as it's at rest in, let's say, a data warehouse or a BI state. You want to be able to catch things a little bit earlier, or a lot earlier rather, so you can not have any of those downstream impacts. So you see a lot of articles out there that talk about data observability being a part of, let's say another pillar of data governance, and it's definitely in the data quality area as well. So I think that data governance, data quality, and observability, none of those are going anywhere anytime soon, obviously, because we know that you need good quality data for any AI initiative that's out there today. So I think it's going to get more and more popular, and we're seeing this trend of people actually understanding what observability means now.
Okay. Yeah, nice.
Yeah. So again, it's this becoming this foundational thing, right, Andreas? That's kind of like the main point is we're just seeing more and more people aware of what that means. And the other part is I think everyone understood what observability was on the application side, whether you have a solution like New Relic or Instana or Datadog looking at your applications or cloud infrastructure. Now that's just moving over into the data space. So these are things, as observability is getting more and more, I would say, aware within data teams and data leadership, probably there's like these three things that we're seeing when we're talking to customers. So the first one is we talked about observability. It's a must-have now for your AI strategy. So it's no longer this nice to have; it's this need to have for engineering platform teams. Whether you're taking pipelines and pushing them to a data lake that they're going to be consumed for your AI initiatives, or you're just pushing data within ML models, ML pipelines, being able to track those things and make sure that there is no failure point, or when there is a failure point, that's resolved quickly. All that is related back to having a good data quality initiative in your organization, so you have a good AI strategy. So that's kind of like the no-brainer. It's like, yeah, no duh, Ryan. The next thing though is that we're seeing a lot of requirements come through that's not just on the modern data stack side, but it's on the legacy support as well. So think about a major organization today, they have things like Airflow and Spark, and maybe even hosted solutions of orchestration, maybe using Snowflake or Databricks, right? Then they also have a lot of legacy needs as well to support. So whether that's a legacy database, it's a legacy orchestration tool, like pipeline tools and orchestration tools like Control M or Legacy Data Stage or anything that's homegrown built, there's this requirement now that it needs to basically merge together. We need to have not just, hey, you support the latest and greatest cloud infrastructure thing, cloud deployment thing. You also need to support this legacy stuff that I have.
I think that is a big point, actually, Ryan, because it's a funny topic because I was talking with someone a few days ago exactly about this, that there's so much legacy applications out there where it's not the newest stuff. Everybody's always talking about the newest topics, the newest tools, but especially large companies, they have so much old stuff that they either don't want to change or they don't have the capacity to actually switch over to new infrastructure, to new tools, where you actually need to have a way of integrating this. Right?
Yeah. I mean, that's a big thing. I mean, obviously, like not everyone, especially on the IBM side, we really champion the hybrid cloud approach for all your business needs, right? So we're not going to force you to go fully cloud or obviously not fully on-prem, and having an ability to have, get access and use the tools you want to use in this hybrid cloud approach. And in that hybrid cloud approach, it's got to have something that supports both legacy, hyperscaler situations, and anything that's related to your infrastructure architecture, right? So that is a big thing. We're seeing that more and more. We obviously look for and can plug in really quickly to a lot of the cloud solutions very, very fast. So we usually start there, but now we're going even more into the legacy tool approach as well, because we want to make sure we have observability across the different tool stacks. And then the last one we're seeing too is this observability and data spanning the tools and process area. So customers are basically requiring data pipeline and quality beyond just your data-centric tools. And Eric's going to talk about this a little bit of how we can connect into things like GitLab or Tektron or other things that may be in your environment today to give you more observability across these tools that aren't just specific to these tools and processes within data. So we're going to talk about that too, because again, the question becomes, as soon as you tie in data observability to one tool, the question is going to be, hey, how can I expand this across all of my other tool sets that I have?
Yeah.
So so when we talk about like how to simplistically, or the simplest way to implement data observability, I think it's important to look at the different, say, categories or use cases that data observability kind of plays in today. And this is from Gartner, the Market Guide to Data Observability Tools that released recently. And you can look at it kind of in these 5 core areas. I've got the 2 main ones highlighted I think you need to do first, and that's like where you're going to have the most time to value immediately when you're actually looking to deploy observability. So always look here first. There's 3 others as well. So the data content area is really the quality of the content you have. So that's like your schemas, your volume, the freshness of that. Data pipeline flow. This is related to the reliability of those pipelines. So it's your states, your durations, your data drifts. The infrastructure and compute, this is, hey, do I have a sufficient resource consumption? Do I have sufficient resources to actually run these jobs or run these flows? And then user usage, utilization, that's more around data usage, data access, lineage, ownership. And then the last one is financial allocation, which is cost optimization, budgeting, and resource allocation. And the reason why we highlight these 2 at the front is because this is where the most of our customers talk to us about today. They may already have tools that give them lineage for user usage and utilization, maybe in catalog solutions. They may already have financial allocation costs with something that is already built into their lakehouse or their warehouse that tells them about, hey, here's how you can optimize your costs. Maybe they have something that flags for sufficient resource consumption. But the main things that they don't have really this observability is around is the data moving in the correct way, and is their data correct, and where are all these different pipelines leading to make sure that I can catch any pipeline failures or data content issues before they get downstream, and it becomes a lot bigger of a problem. So a lot of this, when we talk about these things, sometimes it's called the shift left approach. I was in test automation and DevOps tools in the past, and we always talked about shifting development left, shifting quality left, and testing left. It was basically the idea that you want to catch and test things as early as possible so that you can prevent these downstream, more costly issues. And that's where you tie into the data content and data pipeline area. That's where you're going to find that to be the most time to value immediately when you start to set up something within data observability. So those are the two main areas. The next thing, if you're thinking about, okay, great, if I want to focus on these two areas with data observability, what are some things that I can ask questions about? Well, the first one is looking at this really relates around something around data SLAs, and really what that means, what we're getting to, is most of our customers, when we talk to them today, they want to set up. They're usually managed by the data platform or data engineering team. They want to set up some things around alerting so that they can make sure they're hitting their data SLAs, right? If they don't hit their data SLAs, there's some cost components. You're going to have untrusted data, and you're going to have a lot of angry customers or stakeholders. The data is not delivered to them on time. And the last one, or the second one, is the way to view it is, how can I make sure that I have the custom metrics and assertions ready to go to make sure that the analytics team and the science team is okay with the data content and data validation point. But if you don't get the pipeline execution, latency, and structure set up first, you're going to miss those data SLAs. So when we talk to customers, a lot of times it's, hey, I want to make sure that I can first understand, is my data flowing, right? Is it actually moving? I want to make sure that if we had a pipeline that kicked off and we had no idea that it hadn't even been started yet, that's a problem. Or if it stopped and failed, or there was issues in actually completing, those are all around the pipeline state. We want to be able to know those right away and where to go fix those. The second one is the latency component. So it's like, hey, yeah, let's say that the pipeline is running, but you have a data SLA that needs to be delivered at a certain time during the day, and that is not going to arrive on time. That's a problem. So let's make sure that we can find out when things are stuck in a hung state or maybe ran and failed immediately. And the next one is the data structure, which is the data shape valid and is it complete? Is the schema within that data pipeline, is it going to be delivered to the correct location? And what we expect it to be will actually land in that data store that we're going to send it to. Data content and then data validation, that's kind of at the end of the cycle. We're looking at, were there any significant changes in that data profile? And then the other part is, does the data content conform to how it's actually being used? All these things are important, but to get to like where you should start first, it goes back to the two things we talked about, looking at data content, data pipeline, data flows. And these are the questions you should be asking yourself to figure out, how can we set up alerting and incident management in a way that we can get that time to value with data observability right away, and we're not looking at other nice shiny objects within the data observability landscape. We got to get these things down first before we can actually add more layers to it.
Yeah, it's also interesting because this is basically a blueprint for debugging, right?
Yeah.
Either go from left or from right. If you have problems, that it's very interesting. You first look, okay, is my data is data coming in? Is it coming in on time? And like, is the structure valid, or is the structure how I expect it to be, right? And then you actually move towards this or through this process, and then at the end you see, okay, the data now is valid. Okay, we fixed it.
Yeah. Yeah, and the thing too is, when we talk to customers, they may have tons of different tools that they're using, maybe multiple different orchestration and pipeline tools. They're sending data to lots of different destinations. We try to tell them, like, identify the most critical pipelines you have today. Let's hook into those first, and let's expand the data observability use case. So don't try to boil the ocean. Look for the things that are the most critical for your stakeholders. Let's tie into those, and then we'll add more as we need to.
So that means also they could have already here 1 and 2 implemented, but they're missing 3 and 4 here in this case.
Right. Yeah, and they could be using it. Maybe they said, hey, we want to set this up in an Apache Airflow environment that's hosted in the cloud. We want to wait to, tie into our Control-M on-prem environment, maybe in the future, right? So it's those types of things. We want to make sure that we're helping our customers understand which ones to focus on first.
Cool.
So this kind of gets into, okay, where's Databand play into this, right? We play into really a lot of these areas with data observability, but main thing is we want to be basically the cockpit crew or the operations crew on a Formula One team. So Formula One team, if the whole point is you're driving the car as fast as you can around the track. The car is really important. The driver is really important. But the radio and operations team are the ones that are telling the driver in the car when things are going wrong, what sensors are alerting them on maybe potential incidents or issues and they need to be aware of, and then telling them, hey, you need to pull over, you need to get your tires changed, you need to take this turn a little bit slower. All those things kind of play into it. And that's an analogy for data observability. We're tying into your modern and legacy data stacks to let you know when there's bad things going on, tell you what the resolution is, and hopefully keep you from not going as fast as you can. But we also don't want to alert you on something that may not, or that we don't want to alert you on trivial things, but we also don't want to alert you on very critical things either, or not miss the opportunity to alert you on critical things, because obviously you don't want the car to blow up. We want you to get around the track as fast as you can. And the way this works is really, and Eric will kind of demo this as we go through, but what we do is we collect the metadata that's around your modern data stack. We build these historical baselines to say, okay, this is how behavior should work within your tool stacks. We have lookbacks that can tell us that, and historical data that lets you know how things are moving. And then we create these anomaly alerts that will tell you, hey, this is deviant from what you're expecting. It could be based off of a schema change, a pipeline duration, a data quality rule, whatever that is. And then we kind of route you to resolve the root cause through Slack operations or email or PagerDuty, wherever that is. And so we're removing a lot of the noise that goes on when data engineering teams are trying to push data as fast as they can, and only alert them on the things that they need to take ownership of and fix right away. So that's how Databand works across most of the tool stacks that you'll see when people come to us and talk to us about data observability.
Yeah, I think you mentioned before, like having false positives or errors that are not really errors. That is something that is most annoying to people.
Yeah.
Like you get tons of messages, and then at some point you say, it's everything's wrong, and then you miss the actual problems. So it's a big problem to solve, to not have these or to have some kind of an anomaly detection.
Yeah, and that's the thing. We can have hard-coded rules and alerts set in there, or we can have a sensitivity around the anomaly. So you can say, okay, don't alert me on a deviation of 2 or 3%. Only alert me when it's like an area where I really need to pay attention to it. And we do a lot of ML learning in the background that kind of suggests how the latency should be within your platform or within Databand, looking at these data sets and pipelines. And but again, you can have it to where it's very strict, or just kind of based off of something that is more in a range, I would say. So this is real quick. I just want to quickly highlight this customer story here. So this is a IBM customer story. We have a multinational software corporation. This is an organization that we'll be talking about kind of later in the on our website recently. But we had they had a lot of really awesome things kind of go on in their adoption of Databand. So one was the fact that they had a lot of different data stacks. So they had dbt Core, Airflow, Spark, Snowflake, a lot of different tools in their organization today. They had use cases around process monitoring, inline testing, supporting data products. And when they deployed Databand, they basically reduced their mean time to detection down to 0. So they're able to reduce their mean time to detection, get the resolution up, identify root cause analysis, have these integrations with the different tools, and then be able to really achieve the data quality results that they wanted. And the way they did that was really looking at how we connected with their tool stack. Was we had a bunch of different tools that have our out-of-the-box integrations, so things like Spark and Airflow and Azure Data Factory. But then there's a lot of other tools that they could pull in as well, whether they're integrating with things like Control-M or GitLab or Apache Nifi. what we're doing is we're basically pulling all the pipeline and data sets that are from the metadata in their public data stack or their data stack, pushing that over to the API, and then able to output things like logs, errors, data sets, metrics that we want to report on. So all of that is something that you can do with our public API, or you can use our out-of-the-box supported integrations to do that as well. So with that, I'm going to kind of pass this over to Eric, and he's going to go through just a quick example, one using Azure Data Factory, and the other one using GitLab as a CICD example as well. And he'll kind of walk through the different use cases of what I talked about today within the platform, and then after that, we'll wrap it up with some questions.
Cool. Yeah. Before you start, by the way, let us know the questions. I see a lot of people here. Put the questions in. We are here to help. Yeah, Eric. Well, let's talk about the use cases. I'm excited about this.
Okay. We good now? Everyone can see?
Yeah.
All right. So yeah, like Ryan said, I'm just going to run through a few quick examples here. One with one of our out-of-the-box integrations, and another with this new API that Ryan was mentioning. With most of our native integrations, you're going to find that there's two ways of setting these up. And for the most part, many of these are very simple to get up and running with very quickly. In the case of something like Azure Data Factory, we're simply providing Databand with some information about a service account. We're telling it which factory that we want to monitor. And from that point forward, anything happening in that factory is automatically coming through the Databand.
Eric, can we zoom in a bit in this, because it's a bit small?
Oh yeah, sure. Better?
Yeah, nice. Thanks.
Okay. Yeah, sorry. Yeah, so I've got this monitor set up for ADF now. I'm now in ADF, and the experience here, people who have used ADF, this is very familiar to you. You've got the concept of tasks, just like any other pipeline. These tasks are accepting inputs and outputs. They're generating logs once they run. In some cases, there's some system level metrics being generated. What Databand's doing is we're polling the Azure Data Factory API every few seconds, and we are pulling information back in near real time about the pipelines that are running there. So in my example here, I'm looking at this pipeline called Service 311 Request Analysis. We're basically pulling in some public data from the city of New York, doing some transformations, and then kicking off a job in Databricks. What this looks like on the Databand side is that from our pipeline screen here, this is where you'll see all the jobs that are being monitored by Databand. And one of the nice things here is that we have users who are using multiple tools within their stack. And oftentimes you'll have certain teams that are only responsible for a certain component of that stack, or even a certain, say, like business line or project within that specific product. So one thing you can do here from the UI is to quickly jump into a filter that will let you look only at the assets that are relevant to you. So if I were to filter here on ADF, I've now got my ADF pipelines that I'm monitoring. So I'm going to jump into this one. I can see some overview from previous runs in terms of how long does it typically run, what are the alerts that have fired, what was the state, how did the tasks look. But I'm going to jump into a specific one here to just kind of give you the look and feel of the Databand UI. So from this screen, again, we're collecting all the metadata that's being generated by ADF, and we're presenting that here in Databand in a uniform way across all of our integrations. So over here on the right, we've got the graphical view. This is pretty much one-to-one with what you'll see in your pipeline tool or orchestration tool. We've got the overall state and duration of the pipeline as a whole. We've also got the state and duration of each task, which you could see if I were looking at this in ADF, you can get to the same information, but it's not presented as upfront and easy to access. Sometimes you might have to drill through a few screens. But what this is going to do is to allow us to, right from the start, with just this information alone, we can alert on various things that Ryan was referring to in regards to like pipeline states or task states, durations, and as you'll see in a second, that'll even take us down to the level of things like record counts and schemas. So over here on the left, I've just got some high-level summary information. I'm seeing, over time, what has the duration of this pipeline looked like? Just a quick sanity check to make sure everything looks as expected. Similarly here, we've got a trend for the individual tasks, and I can jump into any of these historical runs very easily if needed. As I click across the top and start to look at the metrics here, we've got a few categories of metrics, but for the most part, these are going to be broken up into pipeline metrics and data metrics. So on the pipeline side, like we talked about, states, durations. So we've got things like compute time, duration, and these are all things that you can very easily create an alert on very quickly. We have streamlined ways of doing this through the UI, but if you just wanted to do a quick one-off alert, it's very easy to just jump straight into an alert definition like this. I can also chart any of these metrics over time down at the bottom, and just, again, kind of a sanity check of seeing how things have looked, seeing if there's any weird spikes in here that we might want to investigate. Like, for example, here, this the duration metric of this validate cluster status task. That's something we would definitely want to investigate. Then continuing across the top, logs, we're collecting logs. Sorry, I'm in a staging environment. We're collecting logs where possible. We're collecting code where possible. This is very dependent on the source system in question. So, you look at a tool like DataStage. DataStage provides logs at the pipeline level. A tool like Airflow provides logs at the task level. Whatever that level is, we can drill into that and show you that debugging information that might help you when these issues arise. And then lastly, we get into the data interactions. And so this is where some of the more interesting stuff is happening from like a data validation standpoint. And as Ryan alluded to, the whole concept of shifting left of the warehouse and the data observability space, there's a lot of focus traditionally on the warehouse level, but our stance has always been that, if the data has already reached the warehouse, then you're potentially, several hours of work into producing that data. You've got people making decisions on it. It's potentially bad data. We need to know about that earlier. So what we are doing in that regard is that, with a tool like ADF, it's very easy to ingest this data set information. So I can see, for example, what is the data that I have read. I can see how many records there were. I can see the record counts over time. And then I can see what data was written along with that schema. And so with these two things here, this is already going to enable a lot of extra alerting. So the most common one that we'll see in this regard is going to be schema changes. You can set up schema change alerts at the individual pipeline level, but we honestly see more people doing it at a higher level, being like maybe the source or the project. That's just going to allow you to do kind of like a catch-all to future-proof your alerting so that you don't have to, keep pace with the new pipelines that you're generating. And then, of course, record counts. This is a good indication of potentially bad data. Sometimes you'll have pipelines that run successfully. Everything is green, but you might come in here and see that there were 0 records. Maybe a vendor or some other team within the company dropped an empty file here. So that data is not helpful for us. And again, we don't want this pipeline to continue running and then kick off, 2 or 3 or 4 more downstream pipelines and have somebody, email the data team 3 hours from now and say, hey, why did our Power BI report not refresh today? Like it still says that the latest data is from yesterday, that sort of thing. So yeah, that's generally, this is the look and feel that you're going to get with any integration within Databand. And of course, as I said, most of these integrations are going to be basically plug and play with your source system, whether that's something like Airflow or ADF or DataStage. And also we have other cases where we have both a Python and a Java SDK, which can help out with cases where you're wanting to log things like Spark jobs. Like that's probably one of our most common use cases is Spark. We talk to tons and tons of customers that use every data stack imaginable under the sun. But the one thing that seems to be consistent from one customer to the next is always Spark. So we do offer some very helpful tools for logging things like notebook or job execution, logging custom metrics, profiling data frames, things like that. Mm-hmm. So with that said, I'm going to shift focus now and talk a little bit about the new API, just because that's one of the things that we are excited about now. So as Ryan mentioned, we've released this API. I believe it's technically still in private beta or private preview, I should say. But the idea here is that, one of the common themes that we hear with the customers that we talk to, especially when we get things like RFIs coming in, is they want to check off as many boxes in their data stack as possible. They want that true end-to-end observability. And the reality is that unless you have a pretty basic data stack, there's not going to be many tools out there that can capture every single one of those points, especially when you start to look at cases where people might be using proprietary frameworks or things developed in-house like that. And so that's the gap that we're hoping to close with our custom integration API. And the way that this is working is that you can create a new integration straight from the UI. And actually, I'm in the wrong one. Here we go. You can create a custom integration here. You're basically only providing us two pieces of information. You're going to you can provide the name of the tool that you're monitoring. We've got for an example here, Informatica. This is not like bound to any sort of list. This is completely free form. This is just purely a way to tag things on your end. And then we have the display name. And this is what, if you remember earlier when we were looking at the pipeline screen, this is what's going to become that source name so that I can easily filter onto that integration if I wanted to. I won't click through this because it's going to generate an access token, and I don't want to redact that in real time. So, but the output of this is it's going to provide you with the URL, and it's going to provide you with an access token.
Yeah. There's a question, Eric. You were talking about AWS, about Azure. Like the question is Databand available on Azure Marketplace, or I would say generally, how is Databand available?
Sure, we're not on Azure Marketplace. Currently, we have two ways of running Databand. We have our SaaS offering, which is the preferred method. It's going to provide the most benefits for the user and easiest management from the user standpoint. We host our SaaS environments on GCP today, but we are I believe within weeks of also offering SaaS on AWS as well. In both of those cases, it's a 100% managed solution. So you can't quite yet go to the marketplace and provision one of these. Like you can still go through the IBM team. But then from that point forward, Databand's managing those environments. Azure, I imagine, is something that's going to be on the roadmap down the road, but for now, IBM in particular, we have a very strong relationship with Amazon, so that's why we're trying to get this new possibility of AWS SaaS out very soon. Aside from the managed solution, we have our self-hosted offering, which is available via both Kubernetes or Docker. So Helm chart or Docker Compose image. And so with that, you can really host Databand anywhere that you want. And to that end, yes, we've seen customers hosting Databand on AKS, on Azure, on EKS, on GKE, on OpenShift within IBM. So really, if there's concerns around a particular cloud provider like GCP or AWS. Maybe you're an Azure user and your security team has not approved Azure as a certified cloud provider. You have the option of deploying it yourself and managing it yourself. Now, of course, like I said, there will be some drawbacks compared to SaaS, but the experience for the most part is going to be very, very close. The main things are going to be, timing of releases. Our SaaS environments are continuously released versus self-hosted, a little less frequently, but for the most part, there's not going to be any major difference between the two.
Okay.
So getting back to the API, at this point we have created our new integration. We've got our URL, we've got our API token. Now, if you review, and hopefully we can share this with the audience somehow, or maybe Ryan, you could even post this in the YouTube chat if you're in there. But we have very detailed documentation for this. We have very detailed documentation for the schema, which columns are required versus not required. And one thing I'll point out is that we actually we've launched this using the lineage, or not the lineage, the schema from Open Lineage. So most people are probably familiar with Open Lineage, open source lineage solution. We talked with a few of their developers in the past, and essentially told them that, hey, you guys look like you have a schema that really fits what we're trying to do. This is what we're thinking of doing. Sound good to you? Everybody was happy with that, and maybe down the road we'll be contributing some additional things to Open Lineage itself. Hopefully that's something we can talk about in the future. But if you've used Open Lineage, it is this schema is directly lifted from that, so it's going to be very familiar. We've got the concept of pipelines and runs and tasks. And so you can get very specific in terms of how you are feeding this information back to Databand. And if you're curious of seeing what this looks like in action, we have a few examples here in our documentation where we have integrated Databand with certain tools. And I'll say that, like this might look kind of intimidating, but keep in mind, this is one of those things where there's a lot of effort up front. As is the case with anything like this, you're developing a framework, and once that framework is in place, it's pretty much in a maintenance state, and it's not going to be this level of effort all the time. Mm-hmm. But essentially, this API, what the main requirement here is that whatever tool you want to monitor is providing open access to the metadata that it's generating. So that's a key thing. Like we've had many people that have asked us about the API and have maybe at times assumed that it's some magical solution where you type in "I'm using Informatica" and it goes and connects to Informatica. It's not like that. There still is work required in terms of mapping your source system to this system, and to that end, like I said, it's required that you have access to that metadata, which in some cases that might not be possible, especially when you're talking about these legacy tools. But for the most part, most modern tools are going to have a very user-friendly API. Worst case scenario, maybe you are the metadata is being stored on some sort of database backend, and in that case, there's still ways that you could shape this to fit that use case. And that's the nice part about this is really the flexibility. You have control over what gets monitored, how things get named, how often this monitor runs, how things get presented in the Databand UI. So it's very flexible in that regard, as long as you've got the necessary metadata. But what we did was, for this call, I was just going to show an example of this using GitLab. So the Databand team, as of a few months ago, we used GitLab as our CICD platform. We've since moved to GitHub, but we did have, once this API work started, we had one of our architects work on an integration with GitLab using this API. And what we found was that, going into this, CICD tools are not commonly something you think of in a data observability discussion. And we were simply looking at this from the standpoint of like, let's just see how it looks. Let's make sure that things are functioning as expected. But once we got this up and running, our developers actually found that this was incredibly helpful. Using Databand to integrate with something like GitLab or GitHub or whatever it may be, it's going to allow you a much deeper level of analysis and monitoring for these CI/CD pipelines. It's not simply a case of, this job fails, send an email to some generic email or to the person that kicked off the pipeline or things like that. We can get very specific about what we're alerting on, how we're alerting on it, who those alerts are going to. And so here we've got the example. This is in GitLab itself, typical CI/CD pipeline. Now in Databand, we switch over here and we've got this recreated here. So now I've got all of my GitLab steps in Databand. And again, remember, like this looks like a lot of tasks, but this is a fairly lightweight framework because it's something you can apply across all of these things in pretty much the same way. But now what this is going to allow me to do is I've got this overall visibility on, of course, the CI/CD pipeline itself. But on top of that, I've got visibility on the individual stages. And sorry, I forget the terminology GitLab uses, but essentially in GitLab, you've got these groupings of tasks, but these tasks themselves aren't really considered jobs. Whereas with Databand, we can treat them more like individual jobs. Like in this case, they're being treated kind of like sub jobs within whatever stage they're sitting in. But now, just like we saw with ADF, we can apply all of those principles to GitLab. So I can see, for example, how's the CI/CD pipeline been running in terms of duration over time. Same thing with tasks. I can drill into a task and see the task durations and states over time. Any metrics that have been generated, I'll see those here and can alert on those just the same. And logs, of course, like if you have logs, you can submit those as well and have those available.
Eric, can you zoom back in a bit?
On the right side?
Yeah, I think as Sahan was writing, can you zoom a little bit, please? I think, yeah, that makes more sense to see a bit more so we can
sure.
read
and
minimum.
let me see if I can, okay, this is the better way, I think, to compare it. So we've got the stages here in GitLab. So we've got build with 1, 2, 3, 4, 10 or so tasks. Here's where we'll see that now, at this top level, without drilling into any logs or anything, we can see that the build stage ran for 5 minutes and 37 seconds. I can see the individual things that are running. And this is where you can start to identify things like bottlenecks. Traditionally, that's something that when you look at something this massive, and I say massive, this is fairly compact. I mean, we've got customers who are running pipelines where they're doing literally like 4,000 dbt tests. And so you've got 4,000 different tasks here available.
Nice.
But this is going to help you identify some of those bottlenecks. And you see like some of these even have like subtasks within them. So it gets down to a very fine grain. And, again, this is in private preview right now. We are continuing to add things onto this. We just completed the contest that Ryan mentioned, which we've gotten a lot of good feedback from that. We're going to iterate on that. And we're going to, I think we've already got plans to deliver data set logging capabilities in here. So GitLab's probably not the best example of this, but let's say that we had some other integration that we don't integrate with, such as like Informatica, just because that's the one that we've been kind of using as our example. Informatica is going to produce, the output information to say, this is the records, this is the schema. We're going to have a way to submit that as well. So you'll be able to have this cohesive view of what everything is looking like, and have it in this central location. And, nice quality of life things like being able to jump to the pipeline, run from Databand, this is something that's common for all of our integrations, but it's just something that helps from like a debugging perspective.
About the debugging perspective,
Sure.
Eric. So when I look at this kind of overview with all the tasks, this looks a bit daunting, right? There are a lot of them. Like, can you show this a bit from a larger perspective? Like when you're in there, you're monitoring or you find a problem, like how would you start? Because most likely you're not going to get into all the details immediately, right? You want to have an alarm, and that leads you then
Sure.
to the overview or something. Can you show that?
Yeah, correct. So yeah, we don't often see cases where people are necessarily using Databand from like an exploratory perspective. Like, someone goes into that pipeline I was just looking at and says, "Oh, let me click around and see what's going on in here." Like, there's probably internal documentation that's mapped all that out already. So what's instead going to happen is that you would define rules against these pipelines. And then once these rules are triggered and they send out to email or Slack or PagerDuty or Teams or wherever they go, what's going to happen is, there's going to be a payload of information that goes to that alert receiver. And then one of the pieces of that is going to be a link that brings them back to the alert detail screen. So this is where you would really start to see people kick off the debugging process. So here I've got some pipeline that failed. I got this notification, let's say in Slack. I clicked on the link from Slack. I'm brought over here. Now I can see all the summary information about this alert. I can see, this was a failure, so it's relevant to see things like the error message, which we highlight very prominently here. We've got the logs as well. And then over here is when you get into the data set analysis, this is where we can do some things with dependencies. So, you've got multiple data sets being processed by a pipeline. Those data sets have their own individual paths. That's maybe S3 : / some bucket, some key, some file. And so we use those paths, and we compare those paths across all of your pipelines. Not even they don't even have to be the same source system. I could be looking at a data set in my data lake that maybe gets produced by Azure Data Factory, then gets read by DataStage, then gets written to Snowflake, so on and so forth. We look for those cases where we have shared interactions across data sets, across pipelines. And that's where we infer some of these, the impact analysis that you see here. So now I've got visibility to go a step farther and say, okay, the pipeline failed, but what is really the impact? I mean, we don't like a failed pipeline, but what's really a risk here? And so we can see now, like, these are the data sets that failed or didn't run today. These are the downstream pipelines that, this is not saying they failed or they won't run. It's just saying they're probably at risk because of some issue. And then we've got missing operations. Like, this is where Databand will learn from observing a pipeline that, this pipeline typically has tasks A, B, and C. Today it ran successfully, but task B wasn't there for whatever reason. That's what we can call out here. And of course, we've got more traditional ways of viewing the lineage in terms of like the graphical view, where you can kind of like drill in and see, like, here's my pipeline that failed. Here's the impacted pipelines downstream.
Nice. Yeah. So, but also these, like here, when we are looking at this, these, let's call them alarms. Like, how are these created? Because when we think back with the GitLab example, there are so many individual attributes of this whole process. Like, how is this set up? Because you don't want to set up a alarm for every one of these individual steps, right?
Yeah, sure. So that's where we have tools to streamline or accelerate the process of getting up and running with most of these alerts. So for basic things like pipeline state, you can see that we can enable these at the entire source system level. We can enable these at individual project levels or at select pipelines. Same thing with run duration. So to that, I would say, if you've got this huge GitLab pipeline that's got 100 steps in it, there's ways that you could streamline the process of saying, okay, alert anytime any of these stages fails. More likely that's probably going to be a little bit too much. So that's where you might start to say, okay, let's just look at the parent stage level. Let's enable a task state alert on the parent level. And if something happens there, regardless of which of the dozens of tasks it might have been, you at least know the stage failed. You can jump over to the alert details. You can jump into the run, and that's where you can start to drill down. So yeah, we are very, very cognizant of both alert fatigue and alert noise, and trying to help people have tools of reducing that, because I mean, like you said, if everything is a problem, then nothing is a problem. Aside from that, we're doing a lot of work right now in terms of coming up with ways to also streamline the process of creating alerts in the first place, like via API. So we have some alerting capabilities via API, but we want to extend that a lot more and make it so that people can, anything that you see here could programmatically be set up via API if needed. But again, for the most part, I would say most of these alert types are going to offer the ability to set up the alerts at a high level and automatically capture all the children under those. Mm-hmm. So that's how you're going to get up and running with some of these massive pipelines.
Okay. Yeah. There's another question, Eric. I think that's also one for you to answer best. Like this question comes. Well, let's just read. How can I get all these data quality pipeline metrics and other metrics to, like, for instance, Power BI? Can I integrate Databand with some presentation layer tools? Is there a way to do this?
That's another API that is on our roadmap, I believe, for this year. So earlier, probably Q1, we released a new API for our customers that will let you query Databand for triggered alerts. And so the use case there that we've seen is that our customers are basically wanting to audit themselves to see how well they're doing it, acknowledging alerts or resolving alerts, as quickly as possible. How long is it taking? What is that mean time to detection or resolution? So we've provided an API that will let you poll your Databand environment for all the alerts that have been triggered over any 30-day window. And then that's very simple to feed into something like a Power BI. The next stage of this is exposing all of the metrics, not just the alerts themselves, but what people are sometimes interested in would be like if I'm looking, for example, at DBT, and I've got some DBT test metrics here. So this is the type of thing that I think the question was getting at was, Databand is now collecting information like, I have all these individual tests in DBT. How many items failed or did they fail? And can I feed this over to, say, Power BI or Tableau or whatever? That's what's coming up on the second half of this year. We are going to be exposing that for users to be able to do that.
Cool.
And of course, we've also got our native dashboard that might answer a lot of the questions you're interested in asking anyway. So this is where you can see summaries of successful pipeline runs over time, in terms of like percentages, in terms of time of day. You can see your most frequently occurring errors, how many times they've happened, when the last time was that it happened. Some information on like which pipelines have the highest failure rates, the highest failure counts, the longest run duration. So there's a lot of ways to slice this information from the native dashboard to answer a lot of the questions the typical person might be interested in.
Nice. Okay. Did you have another use case that you want to share, Eric? Or
no, that was we wanted to cover ADF and the API, so we've done that, and happy to answer other questions if there are any.
I think for me, I really like, as I said before, I really like this API integration, because it gives you so much freedom that you're not necessarily like you're not limited to the tools that you can actually monitor, quotation marks, like that let's say you have an older script laying around where you do some kind of a training of a simple algorithm or applying, just package this in there, and then you can You can actually observe it. I think that is super cool.
And we are hoping, now that the API has been released and we've already seen some example use cases coming in from people, is to at some point have some sort of kind of like cookbook of custom integrations where you could see things see the integrations that have been validated to some extent by the Databand team, and are available to other users. So the caveat there that I would say is a native integration is always going to be the preferred way. So if you're looking at Airflow and you're interested in integrating with Airflow, always use the Airflow integration. Don't try to use the custom API, because these native integrations are just much more. We have so much more control over how and where things are presented, and we just have a lot more control to present things in the way that's valuable to the user. But in the meantime, until those native integrations come out, this is a great alternative, I think.
Yeah. Okay. I don't know what to ask more. I mean, this was very thorough, and I think this gives a lot of insight in how data observability is done right, and what you can do with it, with a tool like this. So
yeah, Andreas, we've got I think you just posted it in there, but there's a product tour that people can go and take a look at. They just want to just see a lot of things that Eric has put together. It's already set up like in a click-through environment. We have a interactive product tour coming out end of this month as well. So it'll be more of like a sandbox experience. So that'll be a fun thing to take a look at too. And then you can always just reach out to us and contact us for a demo. We can do that as well. So a lot of different ways to experience a lot more of the stuff that Eric showcased today.
Yeah. That's cool. Yeah, I also posted the other link. I think that was to the API documentation. Mm-hmm. Yeah, and play around with it. I really like these kind of product tours or test environments where you can just let's just experience this. How does this look? And play around with it. I think that's very, very valuable for people. There was another question, Ryan, around the can you identify a review or something like a Gartner Magic Quadrant that allows potential clients to assess various data observability tools? Like, is there a Magic Quadrant where especially for data observability? Actually, I don't know.
There is no Magic Quadrant yet. If you go to g2.com, Databand's got a lot of reviews. There's a bunch of other like vendors that we would view as competitors that have reviews there too. Okay. We also have the market guide for data observability tools. That's from Gartner. That was out I think about a week ago. So okay. You can take a look at that. It doesn't rank the solutions. It just says what people do. So like for us, we're IBM Databand's in there. It kind of explains where our core things are, and then a lot of others as well. You can take a look at.
Okay.
But always the best way is going to be to get hands-on with it, and we offer free POCs. So feel free to hit us up after the call, and we'll be happy to talk about a POC with you if you want.
Yeah. Yep. What would be the best way to do this? Contact Eric, contact you directly, or what's the channel for people to get in touch?
You can do that, or you can just type in IBM Databand, and on there's a way to select a time that you want to meet with somebody directly just by scheduling a meeting. We're doing a live demo, so
nice.
If you go to you just type in ibmdataband.com, you'll be able to get to that web.
I think we're losing you, Ryan, because like your image is frozen. It was meant as a joke, but I think it's an interesting question. Make some features of this product open source. I mean, would there be a way of having a an open source, a beginner's version of this? Would you say there are some features that everybody should have?
Yeah, we're coming out with so right now there's, if you go to ibmdataband.com, or just if you just go to IBM Databand, type it into Google, on our webpage, we've got like basically different tiers of pricing and packages you can take a look at. We think that everyone should be obviously having some level of observability in play. We don't want everyone to not have something but in place. But I think that where you see a lot of the true power of observability come into play is when you have probably more than 200 pipelines kind of running. So if you're under that, then maybe you may not need the data observability solution. But after 200, we just think that it becomes more and more of an issue. So it may not initially be around the capabilities, maybe around just the scale of how much data you have actually moving
through. We can't hear you anymore, Ryan.
I think it's just lagging between audio and video.
Yeah, something. Yeah, that's true. For not everybody needs it. If you're just at the beginning and then there are ways to monitor this. Maybe also just use the stuff on Azure. But if it gets bigger, then you're very quickly running into trouble.
And just to add on to the open source discussion, I mean, on one hand, making it open source without access to the UI would not be too helpful, just because that's where all the metadata gets sent. So without that, with the actual web application, you're going to be missing out the key use case. But what I would say is, we've got the Python SDK, the Java SDK that we talked about. We're a PyPI library. You can download it through pip. You can do some things in your local environment for sure, and not necessarily contribute to the project itself, but there's a lot of control over helping you to extend the capabilities of Databand, make custom modifications to this or that, or how a certain thing is interpreted or ingested or whatnot. So there is some flexibility there with the SDK, and I just would add that.
I think that's also the right way to do it. That's not everything needs to be open source, but you need to be reasonably open so that people can very easily integrate it, and then at a later stage expand it. I think that's yeah. Okay, guys, thank you for being here, for giving us this overview. As I said, it's for me as well. It's a super important topic, and I hope this gets quicker to the top of the hype cycle, so that more people actually get or see this, and then that it very quickly moves to the plateau of productivity where everybody has an integration for it. Yeah. Thanks, guys.
Yeah. Awesome. Thanks, Andreas.
Thank you.
Everybody follow Ryan and follow Eric on LinkedIn. And we're going to look at the comments here